Hello everyone. In this lecture, we want to mostly talk about the power of data visualization. We want to talk about what data visualization is and why is it important. We consider data visualization a tool to understand the world around us. We make 5 cases to show the power of data visualization. Does anyone know what this is? It's a stained glass window. It's actually the largest handmade stained glass window in the world. It's in Covington, Kentucky, at the Cathedral Basilica of the Assumption. This is our data. And this is what we are trying to do with the data. We are trying to illuminate the data to gain an insight from it. And if we do it well, then we can sometimes tell a story with the data. Numbers don't have to speak for themselves. Rather than numbers, graphs can reveal things that are hard to see in numbers. So graphs can speak for themselves. People remember 20% of what they read, but they remember 83% of what they see. So if we convert this tabular data about motorcycle fatalities in the Baton Rouge region of Louisiana into this interesting visual format, we will quadruple the probability that our audience remember it. In 2010, MIT, in collaboration with IBM, surveyed 3,000 business executives, managers, and analysts from organizations all over the world. They were asked what techniques create more values for the organizations and where are data-driven managers headed in 2 years. As you can see, they predicted that in 2 years, data visualization was going to be the analytical technique that creates the most value for an organization. Now, what is data visualization? These 3 pioneers of visualization defined it in their book as the use of computer-supported interactive visual representations of data to amplify cognition. Edward Tufte, the father of modern data visualization, simply defined it as the process of presenting information through some visible means. Another definition is from Tamara Monzner, the author of one of the best books on data visualization. She went into more detail and said computer-based visualization systems provide visual representations of data sets intended to help people carry out some task more effectively. Notice the 2 words people and effectively in Tamara Monzner's description. So data visualization is like an interface between human beings and data. Data visualization enables us to more effectively perform our task, be it storytelling, exploration, decision-making, or something else. William Edwards Deming was the father of quality control using data and measurements. Many years ago, he expressed the importance of data and analysis based on the data when doing business. He understood that the world is data-driven, and he famously said, "In God we trust, all others bring data." But what do we do with the data, and how much data are we talking about? Billion, trillion, quintillion, or sextillion amounts of data? The answer is quintillion, which is 1 million times a billion. Every day, we create roughly 2.5 quintillion bytes of data. With the growing popularity of mobile devices, this data creation rate will become even greater. Let's look at the magnitude of the internet use. More than 4.79 billion humans use the internet, and its growth rate is at 7.5% each year. Google processes more than 40,000 searches every second, which adds up to 3.5 billion searches per day. And 60% of the web searches were coming from mobile devices. As for services, this graph shows how the taxi sector was hit hard by ride-sharing apps such as Lyft and more so by Uber. Every minute, Venmo processes 68,493 transactions. Spotify adds 28 new songs every minute. Uber riders take more than 45,000 trips, and Wikipedia gets 600 new page edits every minute. Social media is an integral part of people's lives. Every minute, Snapchat users share more than 600,000 photos. More than 120 professionals join LinkedIn every minute. 500 hours of video are uploaded to YouTube. 456,000 tweets are sent on Twitter. Instagram users post 347,000 stories every minute. And more than 1 million videos are viewed on TikTok. That's a huge amount of data. If we add up mobile and desktop internet usage, we realize that roughly 1.7 megabytes of data is created every second by every person in the world. In the last 2 years alone, 90% of the world's data has been created. The data that we start with in big projects is always raw and unorganized. We process the data and make sense of it in order to arrive at various types of information, from which we can start to learn about something or someone. Then we turn that information into knowledge by discovering rules and contexts until we don't even have to think about the information and data anymore. Based on this knowledge, we make decisions and take some actions. Here is an example. We have the exam scores and attendance record for a group of 6 students. This is our data. We perform exam analysis to arrive at different types of information. Basically, we are processing the data and we find mean, median, minimum score, and the maximum score. Then we discover a rule. The student who got the lowest exam score had the lowest attendance rate, and this becomes our knowledge. We visualize the data and we explore a trend, and we now can easily explain the trend. Higher attendance rate leads to higher scores, and vice versa. We then make a decision. For example, we make class attendance mandatory. This is our planning and strategy. It may or may not work. Here we want to go over 5 reasons to visualize the data. Seth Godin, one of the most influential people in the area of online marketing, looked at the power of data visualization from the viewpoint of memory and attention. He said, visual elements allow people to understand what is presented more quickly with less effort. There are 2 ways in which our brain processes information: pre-attentive and attentive. Pre-attentive is fast and happens when the brain takes basic visual attributes and quickly identifies them. Attentive is the conscious process that happens when we actively look for a specific object within a bunch of things. With proper visualization of the data, we absorb more information faster and with less effort. This is because data visualization reduces conscious processing and the memory load, and at the same time, it takes advantage of pre-attentive processing. Power of visualization is about making things pop out at us without really thinking or doing any work. It's about harnessing the human perceptual system to do work for us extremely quickly. Visualization enables us to appeal to our audience's pre-attentive interest. Let's see an example of tapping into pre-attentive visual processes. How many 8s do you see in this data? I'm gonna wait for 20 seconds. It takes a while and still the answer may not be accurate. The correct answer is 12. If I just draw the 8s with a different color, the detection and counting process can be done much faster. Color is one of the most common properties used to call attention. The second main purpose of data visualization can be summarized by the saying from Napoleon Bonaparte: "A good sketch is better than a long speech." Data visualization enables effective storytelling with the data. Basically, it helps us explain and communicate the data or an insight from the data to a specific audience. Let's look at an example, which is one of the most famous visualizations of all time. This example is a visualization of Napoleon's campaign into Russia. In the 18th century, Charles Minard, a French engineer, wanted to present a lot of data about Napoleon's disastrous campaign in Russia in the winter of 1812-1813. He basically wanted to explain and communicate how Napoleon's army marched from Kaunas in today's Lithuania to Moscow, Russia, and retreated all the way back. To give you a little bit of framing, here I'm showing Minard's visualization on a modern map. Napoleon's army marched from Kaunas in today's Lithuania to Moscow, Russia, and then they retreated back home. Now let's discuss the details of it. The light tan colored band shows the advance into Russia, and the black line shows the retreat back home. The thickness of the band shows the number of troops as they advance. The troops start off with 422,000 and only 100,000 of them made it to Moscow. And the temperature during the retreat was plotted at the bottom here on this special scale, which is not centigrade and not Fahrenheit. And as you can see, it gets colder and colder as they retreat back to where they started. The army started off with 422,000 troops. We have a little split up here, about 22,000 troops. They decide to go their own way, and the army is left with 400,000 troops. We have another split up here about 60,000 troops, they decide to go to this Polotsk city, and from there they decide to retreat back and join the main army that were retreating back from Moscow, and they join them. As you see, the army keeps shrinking, and at this point there are only 175,000 of them. It keeps shrinking. At this point we have 145,000. Keeps shrinking and shrinking. And at this point we have about 127,000 troops. And here there is a sudden drop in the number of troops, and there was certainly a battle that the army was facing in here. And finally they made it to Moscow. Only 100,000 troops made it to Moscow. They wanted to conquer Moscow, but for a variety of reasons, such as logistical issues, disease, and weather conditions, they could not conquer Moscow, and they decide to retreat back home. On their way home, the weather got colder and colder, and also they were still facing battles, and hence this sudden decrease in the number of troops, as you can see here and here. So at this point, the number of people alive, the number of troops in the army was just 37,000. Another significant drop here, perhaps as a result of a battle, and as you can see, the weather has gotten very cold. This is way cold. This is like minus 30 centigrade. Another significant drop in here, whenever they wanted to cross a river, they had a hard time because of weather conditions, so they lost a lot of members. At this point, the army gets refreshed because those who decided to retreat early joined them. So the army's size became 50,000. Here, when crossing the Berezina River, they faced a disaster. It was cold, the bridge over the river was destroyed, and therefore the river was impossible to cross. They had equipment issues, and on top of that, they had to battle the Russian army who wanted to trap them. This painting shows the situation. This painting is by Peter von Hess, which shows this battle between the French army and the Russian army by the Berezina River, which is this one. Of the 50,000 troops that had reached the Berezina River, only 28,000 were able to cross it. The Napoleon's march on Moscow was a disastrous campaign. From the original army of 422,000, only 100,000 reached Moscow, and only 10,000 troops were able to return home. This brilliant visualization uses color, location, line thickness, slope, and other parameters to convey the campaign's data in what Edward Tufte described as possibly the greatest statistical graph ever made. As another example, let's say we want to explain and communicate the Affordable Care Act, or Obamacare's insurance gains in 2014. We know that about 10 million more people got insured in 2014 as a result of Obamacare. Now, we want to visualize the data and find what states benefited from Obamacare the most. Here, dark red means extra 10% of the state's population gained insurance, and the bright color means extra 4% or less of the state's population gained health insurance under Obamacare. We can make so many observations now that we have this visualization. For example, we can tell the states with the largest increases in the health insurance rate, These states were Oregon, Nevada, New Mexico, the southern part of Texas, Arkansas, Kentucky, and West Virginia. Here is a nice graph visualizing the breakdown of 34,522 calls made to 311 in New York City in a week in September 2010. The visualization plots the nature and frequency of these calls over time of day. It nicely conveys what these calls were about and when they were placed. For example, calls about property taxes in blue color here, they were only placed during the daytime. Or another observation that I can make is that calls about noise, they were placed mostly during the nighttime with an obvious peak at midnight.